In this video, we are going to understand what is a thread and what is the basics of a thread, what is the life cycle of a thread, and also we are going to learn how we are going to create a thread in Python. So first we are going to talk about a thread now. So earlier we heard about a process. So earlier we know what is a process. So simply we say that a process is a program. It is a program in execution is called as a process, and we are going to denote this process by using a circle. And also this circle or this process is divided into 4 parts. As we all know, it contains your data segment, it contains your core segment, it is going to contain your stack segment as well as your extra segment, or sometimes I can also call it as your heap segment. So these are the areas which are created whenever I create a process on your shell. Okay. Now, so if we create n number of, suppose on the shell on your computer, we are going to create n processes. So if you are going to create n processes, it means that we are going to create n number of circles are being created, n number of n into 4 segments are created on your shell, and which may reduce the computation speed of your computer or your CPU. Okay, so with the increase in the number of processes on the CPU, there is an every possibility that it can reduce the computation speed of a computer. So now for increasing the computational speed of your computer, or for increasing the efficiency of your computer, now we are going to introduce a concept here called threads. So a thread is similar to a process by which we can increase the computational speed of your computer, or otherwise we can say it can increase the efficiency of your computer. So these threads are denoted by. So we are going to denote this thread. So we are going to denote this thread not with a circle, but we are going to denote this thread by using a symbol like this, a crooked line, or which is called as, we can also call it as my string. We can also call it as a string image. So whenever I want to represent a thread, so we are going to draw this diagram, and whenever you see this diagram, then you need to understand that it is being treated as your thread. So now we'll see what happens and what is a thread and what is the difference between a thread as well as a process. A process, so if I talk about a process, and one of the most frequent example which we can understand about a process is your web browser. So we all know why we are going to use this web browser. So whenever you want to interact with the internet, then we are going to open the web browser and we can download and upload the contents from the internet. So this is the best example for the process. Okay. So whenever I say process, what happens internally on the OS? It is going to create a circle, and then it is going to create 4 areas. So all those things are going to happen whenever I say it is being treated as a process. Okay. Now, so there is a possibility that within the web browser we can play videos, we can play or we can listen to your audio files, And we can even play the games on the browser. We can also play the games on the browser. So these are different applications which can be done within your web browser. So these applications which can be executed in the web browser, I call it as your task. I call it as your task. So whenever I create or whenever I initiate a task, the web browser is going to create a separate thread for this. Means we are going to create a thread for a video. It is going to create a thread for an audio. It is going to create a thread for the games and etc. So with this scenario, what we are going to have, what we are going to understand, we are going to understand that if I denote it is a circle, means it is a process. So in the process, we are going to create threads, and these threads are going to perform multiple tasks. So, isn't it? So with this example, now we are able to understand what these threads can do. We can also call these threads as my task also. So for performing multiple tasks, we are going to take the help of these threads. Okay. So now we are able to understand what is the difference between the process as well as my threads. So the first and foremost thing we need to understand is whenever I want to create a thread, there should be a process. Without a process, we cannot create a thread. And a thread can also create another thread. So I just write that information also for you. For creating a thread, there should be a process. A thread can create another thread. Okay, I think now we are able to understand what does it mean now. So whenever I want to create a thread, there should be a process. And in turn, a thread can also create another thread. So I think now we are having a clear idea what is a process and as well as what is a thread. So now we go ahead and understand what are the features which are there for this thread. As we all know, every process is identified by process ID. Every process is identified by a process ID. In the same way, every thread is identified by a thread ID. And as we all know, your process ID will be an integer, and as well as my thread ID will also be an integer. So it means that when we are going to have multiple threads performing multiple tasks, so for identifying these multiple threads or multiple tasks, we are going to identify them by using your IDs. So now we are able to understand what is your thread ID. Every thread is going to contain a thread ID. Now we'll see how we are going to improve the efficiency of multitasking, or we said that in multi-processing. And otherwise, if you talk about multiple processes, whenever you are going to have multiple processes, as we have said, the efficiency of your computer is fall down. Now we'll see how we are going to increase the computational speed of a computer by taking the help of your thread. So whenever you create a thread, so we are going to create a thread. Okay, so we are going to create multiple threads, and all these multiple threads are going to share the areas of the process which created them. which created them. In the earlier case, in the earlier what I said to you, whenever we are going to create a multiple processes, we are going to have multiple circles are created. And for every circle, we are going to have different areas. Now, what I said now, every process, now, if you are going to create multiple threads, okay, all these threads are created by the process. And all these threads which are created by the processes are going to share the areas. Otherwise, I say segments. Sometimes we can also call them as your segments also. So we can use the segments of the processes, right? All the threads created by that processes are going to share the areas. They are going to share the areas or segments of the processes which have created them. It means that we are going to save the memory. Whenever you say that we are going to save the memory, it means the computational speed of a computer is dependent upon the memory it is been using for its execution. So now we are going to use less amount of memory. So when we use less amount of memory, it means that we are going to increase the efficiency or computational speed of your computer. So this is how we are going to increase the computational speed of your computer. Okay. Now we go ahead and understand. And now we are going to understand the life cycle of a thread. Now we are going to understand the life cycle of a thread. And the life cycle of a thread is almost similar to your process. Okay. So this life cycle is going to contain newborn thread. So it is the first stage we are going to happen. Then from it is going to send into the ready state. From the ready state, we are going to jump into another state called running state. And from the running state, we are going to enter into terminated state. Okay, so from the running state, we can be sent into a blocked state. And from the blocked state, we are going to enter into the ready state. So these are the different stages. Whenever I create a thread, these are the different stages which we are going to have for a thread. So first stage is newborn thread. Whenever I create a thread, we are going to enter into the state called a newborn state. From there, we go into the ready state, and where we are going to see whether all the resources which are needed for execution are there to the computer or not. If they are there, then we enter into the execution phase where we start executing the instructions of the program. After that, we are going to send into the state called terminated state. And while executing the instructions of the code, if there is a possibility of waiting for another resource, then we are going to send into the blocked state. And again, from the blocked state, we enter into the ready state. So these are the different stages which we are going to have in your thread life cycle. Now we are going to see how we are going to create a thread. So we are going to have a small example how we are going to create a thread in your Python program. So just I will be sharing a code here, so by which we are going to understand how a thread is being created and what are the uses of each and every statement we are going to understand. Okay. Okay. Now it is a very simple code here. Okay. So whenever I want to create a thread in Python, so first and foremost thing we need to do is we are going to import a module called as threading module. So what is the first step we need to do whenever I want to create a thread? First of all, we need to import a module called threading module. And then we are going to write a method. Okay, so as we all know from the basics of Python, whenever I want to write a method in the Python, what I do, I start with a definition, then we are going to write a method, a name, and a semicolon. And in this method, we are going to have the executable statement. So whatever the statements which I want to execute in this thread will be a part of this function. And then after this function, now we are going to declare a variable, any variable. So for my understanding, I'm going to take it as a t. T is equal to threading dot thread. So this threading we are going to use here. Then I call dot thread and I say target is equal to task. So this is a keyword and we can't change this word. Now this because your program is having the method called task, we are going to specify this as a task. Suppose if your function is ABC here, then what we are going to write here, target is equal to ABC. So whenever I call that method, whenever I want to call that method, simply I say target is equal to task. Okay, then we are going to begin the execution of my thread. So whenever I want to begin the execution of my thread, then we are going to say t dot start. So whenever I say t dot start, then it starts executing your thread. Start executing in the thread, it means that it will execute all the instructions which are there in the method called task method. Okay, so this is a very simple example. Okay, this is a very simple example which is going to create a sample thread for you. Now we are going to see the very interesting methods which are there as a part of my thread. Okay, so the first and foremost method we are going to talk about is your start method. The first and foremost method which we are going to speak is your start method. Unless you call this method, okay, you cannot start my thread. So for begin the execution of your thread, we need to call the method called start method. So it is compulsory. So whenever you want to start the thread, definitely you are going to call the method called start. Then after that, we are going to have one more interesting method called run method. Run method. Okay, whenever or whatever the instructions which I want to execute in this thread, okay, then those instructions should be kept under the method called run method. Okay, so we'll say this method is going to contain instructions to be executed. Okay, then we are going to have one more interesting method called a sleep method, which we are going to encounter very frequently. Okay, whenever I say sleep, sleep is going to send your thread into a blocked state. It is going to send into a blocked state. So whenever you call the method sleep, the executing thread will be sent into the blocked state, and another thread executing simultaneously will get the CPU and it executes the instructions of the program. Now we'll take a small diagram of this. Suppose I am having thread number 1, I'm having thread number 2, and I'm having thread number 3. So I name it as T1, I name it as T2, I name it as T3. Suppose at some point of time in the course of execution, suppose I'm executing a method called sleep1. 1 indicates, suppose the sleep is going to take an argument which is an integer. Okay, this integer specifies how many seconds I need to be blocked. How many seconds I need to be blocked will be specified by this integer. Suppose if I say 1, it means your thread is going to be blocked for 1 second. If I say 10, it means your thread will be blocked for 10 seconds. If you say 100, it means your thread is going to be blocked for 100 seconds. Now, I say sleep 1 here. So whenever at this point I say sleep 1. So whenever I say sleep 1 here, the execution of this thread is stopped here, is stopped at this point, and will be jumped onto the simultaneously executing threads. So the simultaneously executing threads are T2 and T3. And we cannot define whether I may go to T2 or I may go to my T3. Okay, I may go to T2 or I may go to T3. Suppose I say I entered into my T2. So I am executing the instructions for 1 second here. So after executing 1 second instructions of this thread, now this time is been elapsed. Okay, so whenever this time is elapsed, switching happens. It means it stops the execution here and then come back to this thread and continue the execution of this thread. Okay, now I think now you are able to understand what exactly the sleep will do. So whenever you say sleep, means you are going to stop the execution and the control or the CPU is shifted to another thread which is executing simultaneously. So now we are in your multiple tasking, right? We are executing multiple tasks. We are executing multiple tasks. So I think now you are able to understand what is the importance of the method called start. And then we are going to understand the run method, sleep method, and one interesting method we are going to have is join. Suppose I executed join here. Okay, at this point I executed the method called join. So whenever I execute join here, this thread will not execute further until all the threads of that process are being executed. Means unless these threads are terminated, I cannot get the control here. So whenever you want to stop a thread, then until another threads will execute, then what I need to do, I need to call a method called join method. So if I execute my join method, until unless all the threads are executed, our thread will not be continued. So this is a very simple example how we are going to use all the methods here. Okay, now we are going to see a program in which how we are going to create multiple threads in Python. So just I have the code with me. Just I'll copy down that code that will be saving our time. Okay, then I come down here. I just copy down the code here. Okay. So that I can save some space. Okay. Okay, done. So now this is a very simple program, okay, by which we are going to understand how we are going to create multiple threads in your Python program. So as you all know, we are going to import the module called threading. And whenever you are going to use the method called sleep, okay, then we need to import a module called time. So now we are having a method called task, which is going to take an argument. So I call it as an argument. Okay. So now in this method, what is happening now? We are having an iterative statement where it starts until your range 3. It means 3 times it will be executed. 1, 2, 3. Okay. So then it is going to print the argument same array, argument name and running, and then I will say sleep. Okay. Right. Then so this method is having a for loop. Okay. And in the for loop, we are having one input statement and then a sleep method. Okay. Then we are going to start my thread. T1 is equal to threading. As you all know, dot thread. Target is equal to my function name, then arguments is equal to thread 1. So the first argument is thread 1 and the second argument is my thread 2. Then I say T1 start as well as my T2 start. Now we are going to have a diagram now here. Okay, I name this as a T1. I name this as your T2. Now I say T1 dot starts. Now I start executing here now. Start executing here means this thread is containing this function. I call this function. I go here. Now the value of my I will be equal to 1. And I say name. What is my name? Thread 1. Thread 1. So what we are going to print now from my T1, we are going to print thread 1. Okay. After printing this, thread 1 running. I'll say thread 1 is running. Then after executing this one, now we are going to execute a method called sleep. So now you say we're executing sleep here. So whenever you execute the method sleep here, what happens? The control is shifted to another thread which is executing simultaneously. So I go to my thread 2. So what my thread 2 will do now? Again, it is going to call the same function. Okay. And then means that this T1 is having the same method called task and your T2 is also having the same method task now. Okay, this thread 1 and my thread 2 are having the same functionality but with different arguments. Here I am sending thread 1 as an argument, and here we are going to send thread 2 as an argument. Okay, now I'll say okay, now whenever I say sleep, what happens now? I go to this thread and I start executing this method. So in this method, what is there again? Again, we are going to start my T2 in my thread. Again, what it is going to print? It is going to print thread 2 running. So after executing this thread to running, again we are going to say sleep. Whenever I say sleep here, now where my control goes, my control is shifted back to my T1. First it is been shifted to T2. Now it is been shifted to my T1. Now again what my T1 will do, my T1 again will execute T1 thread 1 under running. T1 is under running. Now after executing this again, what happens now? Again we execute sleep. Whenever I execute sleep, again control jumps back here. Now whenever I say jumping back, it is going to gather the previous location. Where is the previous location? It says T2 thread 2 running. So it happens for my third time also. So I think now you are able to understand with this example how shifting is being done built between multiple threads. Okay, so this is a best example how we are going to utilize my thread for executing different tasks. Okay, now we go ahead. Now we can also have, suppose I can write a method ABC. I can write a method ABC and I can write another method called function. Okay, this will have a separate implementation and this can have a separate implementation. Okay, now whenever I want to start a thread for ABC, what I can do now? I can say now T1 is equal to threading dot thread target is equal to ABC, which will execute this thread. Now we are going to create another thread. Threading dot Right. Target is equal to function. Now, what is happening here now? First thread is created and the execution of this thread will be done for the instructions which are there in the method ABC. Okay. And the second thread is executed for the method function. It means what is happening now? It means we are executing the methods of ABC and we are executing the methods of the function simultaneously. Actually, if you are not having a thread, what happens? Until unless I execute the instructions of my ABC, I cannot execute the instructions of my function. But now here, what is happening now? We are executing the instructions of the ABC. Simultaneously, we are executing the instructions of your function also. So this is how we are going to achieve the concept called as multitasking. So using my threads, what we are going to achieve? We are going to achieve multitasking. So I hope you all understood how we are going to create a thread, how to create a single thread, how we are going to create multiple threads, all those things. In the next video, we are going to talk about how we are going to synchronize different threads which want to handle a single resource. Thank you. We all know that now this image represents a thread. So in this diagram, we are having two threads, okay, where we are going to name it as T1 thread as well as we are going to name it as T2 thread. And these two threads will execute concurrently. Okay, concurrently means, so while executing the instructions of this thread, okay, it executes the instructions of this thread also. So the instructions of T1 as well as T2 will be executed concurrently. So while executing the instructions of two different threads concurrently, there is a possibility that we may have a race condition. So we may encounter a situation called as race condition. So now we are going to understand what exactly the race condition is and how we are going to avoid this race condition in your Python. So first, first of all, we need to understand what is a race condition. Suppose in between T1 and T2, okay, there is a resource. Okay, so assume that there is a resource in between them. Okay, we call this resource as a shared resource. We call this resource as a shared resource. So when you say it is a shared resource, it means that this thread can access these variables as well as this thread can also access these variables. So if both the threads access the same resource, so then there is a possibility to encounter a condition. Now we call that condition as race condition. Now we are going to take a small example, and with that example we are going to understand how a race condition will occur and how we are going to solve this race condition in your Python language. I think now you all understood what is your shared resource as well as what is the race condition also. Okay, now we go ahead and see. Okay, so first we'll see how we are going to create a lock in your Python. So whenever I want to create a lock in the Python, so what we are going to do is just we are going to import the module called as threading module. So whenever you want to create a thread also, we are going to use the same module. So the same module is used for creating the threads as well as it is used for synchronization also. Synchronization means that whenever I use the word synchronization, when this thread is under execution, the second thread which is executing simultaneously will not execute. Okay, when your T1 is under execution, T2 will not be executed. And while T2 is under execution, T1 will not be executed. So if there is a compromise in between T1 and T2, then we'll say these two threads are called as synchronous threads. We call these threads as synchronous threads. So for developing these synchronous threads, we are going to use your locks. We are going to use the lock sometimes. In another cases, we are going to talk about monitors also. These locks and monitors are used for synchronizing the threads. Now we'll see how we are going to keep the locks in Python. So when I want to create a lock, so what I do is I'll be using the method called lock. Threading.lock. Okay, thread lock is equal to, so your lock is a variable here. Lock is equal to threading.lock. Okay, so this is going to create a lock. Okay, now we are going to create a variable here. Okay, and we call that variable as a shared variable. So whenever I say it is a shared variable, it means that both the threads which are executing concurrently can access the value which is there in that variable. Okay. So now we'll see how, So now we are going to declare a variable here called count is equal to 0, right? So the variable can be, so this particular variable can be accessed by the multiple threads. So when this particular variable should be accessed by multiple threads, so what we need to do is we need to make this variable as a global variable. So what I should do? We need to make this variable as a global variable. And in Python, I can easily make a global variable by adding a keyword before that variable with a name called global. So now this counter is now going to become a global variable. Okay, and this function, okay, whatever the function now we have can be called or can be executed by different threads. Okay, so when I want to acquire a lock, so in Python, while executing the thread, if I want to acquire a lock, just simply I'll be calling a method called acquire. So when you acquire a lock on a particular resource, it means that unless I unlock it, okay, no one can use that particular resource. No other simultaneously executing thread can utilize the data which is there in this particular variable. So this counter variable, which we are going to use, which can be accessed by multiple threads now, can also be called as a special section, and I can also call it as your critical section also. We can also call it as a critical section. Okay, we can also call it as your critical section. Okay, now we'll see. So in the critical section, what we are going to do now, we are going to have an instruction called counter plus is equal to 1. So it means that if I elaborate that particular statement, so that instruction will be counter is equal to counter plus 1. Okay, so this particular instructions contains, first it is going to contain the operation called as a read operation. Then it is going to contain the operation called as modify operation. And then it is going to contain the operation called as your write operation. So if I say counter is equal to counter plus 1, it means that that single statement have read operation, modify operation, as well as write operation. So when you have read means, first of all, whenever I say counter, it reads the data from the resource. Okay, then modify, we are going to add the value to it, and then the updated value is been stored into the counter again. So this particular statement, counter is equal to counter plus 1 or counter plus is equal to 1, have 3 operations: read, modify, as well as write. So after acquiring the lock, now we are going to release the lock. So whenever I want to release the lock, so simply I use the method called release. Okay. So the better way which we can use this lock is, I can simply write with lock counter plus is equal to 1. We can also use this particular statement instead of saying lock dot acquire and all. We can simply use my with lock counter plus is equal to 1, which automatically requires the lock recommended method. So now I will be explaining you how to create multiple threads. Okay, suppose I say I'm having a thread called as T1. So whenever I want to execute my T1, T1 is equal to threading.thread. Target is equal to increment. It means one thread is created. Okay. When I say T2 is equal to thread, then we are going to create another thread. Okay. Whenever I want to start the execution, then we are going to call the method called start. Okay. Now we are going to use a method called join. So unless I execute this join, and so if I execute my join, what happens here? This thread is executed until this is completed. Okay, and I also execute my T2 join. T2 join is also going to wait for another threads to be executed if they are. If there are no other threads, just simply I'll execute first and then later I execute my first thread. So this is how we are going to create the lock. So the summary of this content is, first of all, we are going to import the module threading. We create the lock. We understood the concept of my shared resource, create, acquire lock, critical section, release the lock, and running the threads. So this is, now we are going to see a small diagram now. So what happens, right? What happens if you don't have a lock? And we'll see what happens if we have a lock. Suppose I am executing my thread 1. My thread 1, I say read x is equal to 0. We are going to read the value to 0. And we are updating the value x is equal to x plus 1. So now the value will be equal to 1. Then we are going to say the value of my x is equal to 1. Okay, done. Simultaneously, we are executing the same thing. Basically, the value of my x, we are having a value there is equal to 0. So the same thing is going to happen here. X is equal to 0. Then what happens? Again, we are going to say x is equal to 1. Means 0 plus 1 is equal to 1. And we are going to store the 1 into x. So now this x is equal to 1 will be stored into that particular variable. So this is called as my race condition. Okay, and this example is for we get this x1, we get this situation when there is no synchronization between the threads. Now we'll see what happens, right? If you see what happens if we are going to keep a lock. Now we need to understand, suppose I say we are executing these instructions for this while. Okay, till this point I executed. Okay, and I shifted the control here at this point. At this point, I shifted the control. If I shift the control again, the value of my x is equal to 0. Okay. Now this variable is different for this thread and this variable is different for this thread. Okay. This thread is going to contain a variable and this thread is also, this is x is equal to 0 and this x is equal to 0. Okay. Right. Now, x is equal to 1. I am executing this thread. Okay. X is equal to 0. Now what it is doing now, it is incrementing the value to 1 now. After executing the 1, we are updating the value 1 and we are going to print the value. Now what happens? Already x is equal to 0 there. Now again we are going to update the value to x is equal to 1 and we are going to write the instruction. It means that there is no change. Whatever the output which I am expecting there is not there as a part of it. So now for avoiding these race condition, now what I do is now we are going to approach the concept of my threads. We'll see what happens now. So first my thread 1 is executing. Before executing any IO operation, what I do, I'll just keep a lock and inform other threads also, right? I am keeping a lock now. Okay, whenever I say lock, this thread will not interfere in its execution. Okay, so now what it say now, x is equal to 0, x is equal to x plus 1. So the value of my x is equal to 1. Okay, now we are going to say unlock. So whenever I say unlock, now the execution begins from here now. So now whenever I say unlock, so what happens now? The execution begins here now. Now I say, what is the value of my x here? The value of my x is equal to 1 and x is equal to x plus 1, where the value of my x is equal to 2 and the value of my x is equal to 2, which is being expected. Means that we are going to solve your race conditions, right, by keeping the lock. Okay, so now we are able to understand what are the methods I use for keeping a lock and how this lock is going to work. Now we are going to have a sample code, right, how we are going to keep a lock and all those things we are going to see. Okay, Now, first, we'll see what happens without a lock, and the same code we'll see what happens if I keep a lock. Now, so what I do is first, for applying the concept of my threads, just I import my threading. I say counter is equal to 0, and I make my counter as global here. So the name of my method is increment. Okay. Now for in range 1 lakh, counter is equal to counter plus 1. Now we are going to create my thread 1. Okay, we are going to create your thread 2, and we are going to start your thread 1, as well as we are going to start your thread 2, and we are going to wait for their completion. Okay, and now if you see here, the expected is 2 lakhs, because one thread increments from 1 to 1 lakh, and second thread increments from 1 lakh to 2 lakh is expected actually. But the value you get here will not be 2 lakh. It is something else, right? So why it is happening? Because it is not been synchronized. So if you can execute this program and see, you will understand that the value is different other than your 2 lakhs. Now we'll see what happens if you are going to keep the lock. Now what I do now, just the same thing is going to happen now. Import threading, counter is equal to 0. We are going to keep the lock now. As we all know, we are going to keep a lock by using this particular statement. Then the same thing happen now. With the lock, I am saying. Now, whenever you say lock, it means that is fixed. Means until unless I complete the execution of my thread 1, another thread will not be executed. Okay, until unless I execute completely this thread, I cannot execute my thread. So if I execute this thread completely, the value will be equal to 1 lakh. And if I execute this thread completely, the value will be equal to 2 lakhs. So if you execute this particular program on your computer, then you will understand what exactly will be the output. So now the expected output is equal to 2000, and which is been done by applying the concept of your logs. I think now you are able to understand what is critical section, what is the race condition, and how we are going to avoid the race condition with the help of a small example. So in the coming videos, we are going to understand all the IPCs which are available. Thank you.